example is a case study example, and it combines life cycle costing with EMA. So Volt Company generates and sells electricity. It operates a nuclear power station, and the costs and output of the power station are detailed below. The nuclear station can generate 9,000 gigawatts of electricity in each of its 40 years of useful life. So if you see that of 9,000 times the 40, that would be 360,000 gigawatts. Operating costs are 486 million for the year, but operating costs include a provision for depreciation of 175 million. This is to recover the 7 billion cost of building the power station. Each nuclear station has estimated decommissioning costs of 12 billion at the end of its life. So the first requirement says, what is the life cycle cost per gigawatt of the nuclear power station? To the nearest 1,000. So what we need to do is find out the total costs over the life cycle and then divide it by that 360,000 gigawatts, which is 9,000 gigawatts for each of the 40 years. So first of all, let's start with the operating costs. The operating costs are 486 million per year, but that includes this provision for depreciation. We're going to count that within that 7 billion. So therefore we need to take that 170 million out of the 486 million. So 486 minus the 175 equals 311 million. We times that by the 40 years, and that gives us 12,440 million. Then we add the building. So the building was 7 billion, which is 7,000 million. And then we add the decommissioning, which is 12,000 million or 12 billion. We add all that together and we get 31,440 million. Now we need it per gigawatt, so therefore the 31,440 million needs to be divided by, see all those zeros, it needs to be divided by the 360,000 gigawatt hours. And if you divide that by the 360,000, you will get 87,333. It might be easier if you cross off those zeros and you divide 31,440,000 by 360. That gives you 87,333. We have to do it to the nearest 1,000, so therefore that is 87,000 C. Now let's go on to part 2. Still using the same scenario. Which of the following will decrease the total life cycle cost of the nuclear station? Now they're asking for the total life cycle cost, not the per gigawatt hour cost. So the increasing the useful life of the station, that may reduce the per gigawatt hour cost, but no, it would definitely increase the total life cycle costs because you're operating the nuclear station for longer, therefore incurring more operating costs. So that is wrong. Number 2, reducing the decommissioning costs. That absolutely would work. If we were able to reduce the 12,000 million, that would therefore reduce the total life cycle cost. So the answer is B, 2 only. Now let's move on to part 3. How would the disposal cost of spent nuclear fuel be categorised in the environmental management accounting area? Would it be a prevention cost, a detection cost, an internal failure cost or an external failure cost. Now remember, the spent nuclear fuel is wastage that is disposed of. So therefore, that would be an internal failure cost. It's not an external failure cost. That is clearing up pollution. So because we are disposing of it in a clean and environmental way, that would be an internal failure cost.